Hey guys, Mr. Jenkins here. This will be 2.8 notes. This is your last section of chapter 2, so we'll kind of change gears into review mode after this. So your learning target for this lesson is basically that you can graph a two-variable inequality if given, if provided the inequality, and then vice versa. So you can also provide the inequality when given the graph. All right, so a linear inequality with two variables, so that's what this lesson is about. Hopefully my pen will keep up today. We'll see how it goes. We'll go with some green here. So a linear inequality with two variables whose graph is a region of the coordinate plane that is bounded, I guess that's the word, by a line. The boundary line separates the coordinate plane into two parts, one of which consists of the solutions to the inequality, and then the other of which doesn't. All right, so here we go. Looking at example 1, just a very basic one. You know, for our boundary line, for our boundary points, we're basically thinking about y equals 3x minus 1. So just a line and slope intercept form where my y-intercept is -1, 0, -1, and my slope is 3. So that could be up 3, right 1. It could be down 3, left 1. And then I like to go across the whole graph when I'm doing this manually, although you guys really won't have to worry about this with Math Excel and everything. But before I just trace my line, I have to remember here whether my boundary line is solid or dotted. So this says y is strictly greater than 3x minus 1, right? So strictly greater than or strictly less than would give you a dotted boundary line. Okay, so something like that, and then we have to figure out which side of the line do we shade. So, well, you might just be able to tell where would the y's be that are greater than that boundary line. Well, they'd be above it. In this case, above and to the left. But if you're not sure, I would say that the 0-0 test in most cases is a good way to figure it out. So like I said, if you're not sure, you can test. As long as your boundary line doesn't go through 0-0, you can test with 0-0. So here's what I mean by that. So if you sub in 0 for x and 0 for y, just see if it's true or false. So into the original, that would be 0 is greater than 3 times 0 minus 1. So 0 is greater than 0 minus 1. 0 is greater than -1. So is that true or is that false? That is true. So we want to shade on the 0-0 side of the boundary line, which you can see we have. Okay, so hopefully that makes sense. Example 2 will be on the notes. I'm going to go ahead and skip it. So one thing you'll want to take note of is that it will be a solid boundary line. You might want to try that one on your own and check. Example 3, obviously going to be a little bit different. Okay, so a little bit more going on there. So this one is not in quote unquote slope intercept form, you know, per se. I'm going to rewrite it just so it's all together. So it's 1 minus y is less than the absolute value of x plus 2. So we want to get y by itself, get it in slope intercept form. So the first thing we want to do is move over the positive 1. So when I do that, I would get negative y is less than the absolute value of x plus 2 minus 1. And then I'm going to multiply everything by -1. And so one thing that happens that we'll tend to forget there is you want to flip your inequality symbol. Remember, when you multiply or divide by a negative, that's what happens on these. So we get y is greater than actually, let me look at that real quick. I don't want to tell you guys the wrong thing around the inequality symbol. Let me pull out the filled out notes. Give me just a second. Sorry about this. Want to make sure I get it right for the video, though. What I'm looking up real quick is what happens when I multiply, this by -1. Do we do anything with that? That's what I'm looking for right now. So I'm just pulling it up. I know that -1 at the end obviously becomes +1. I think you just put a negative outside the absolute value bars. There you go. Okay, so yeah, you do put a negative outside the absolute value bar. So that acts as a like a reflection. That's what I thought. I just wanted to make sure. So just to be clear, sorry about the confusion there. What I'm doing is I'm multiplying the whole right side of the inequality by -1. Okay, so basically you're distributing the -1. So that gives me -1 times the absolute value of x plus 2. Keep doing parentheses there, and then +1. All right, so just kind of going back to last lesson, and remember you can always punch this in to see the boundary line on your graph just to make sure, which I'll review that again in case you missed it on the last lesson, but let's go ahead and think through this together. So first of all, my vertex, remember, so that's going to be left 2 from 0, 0, and up 1. So that would be my vertex at -2, 1. And then a normal absolute value would go like this and this, right? But then the -1 is going to flip it upside down. So then I'm going to go kind of this way with a -1 slope on this side and a +1 slope on the other side. All right, in this case, my boundary line is also going to be dotted. And then we want to figure out which way to shade. So you look at your last one. So greater than is going to be above. But remember, you can always do the 0, 0 test. And for that, I would always go back here. So if I sub into the original, I would have 1 minus 0 is less than the absolute value of 0 plus 2. Jeez, done that every time. So that gives me 1 is less than 2, which is true. So you would want to shade on the 0, 0 side, which is where we shaded. Okay. So last note on this, I know that boundary line was a little bit tricky, talking about graphing this. So I want to just show that in the graphing calculator real quick. So we're doing -1 or just negative times the absolute value. So remember that's math. Go over to number, option 1. So absolute value of x plus 2. And then arrow out, and then add the +1 on the end. And then you can look at your graph. And you can see that it is kind of what we had right there. Okay, and remember, if you can't tell by looking at the graph, you can always go to the table by hitting second graph and get those ordered pairs. Okay. All right, so moving on to example 4. It says what inequality, what inequality does the graph represent? So a couple things here. The first thing is, we'll just make it simple. We're going to put it right in slope-intercept form. So y is Would it be greater than or less than? It's going to be one or the other because it's dotted. Above is going to be greater than, so y is greater than. Then we got to figure out how to write the equation for this boundary line, right? So first thing I notice is that the slope over here is +1, over here is +1, so there is no a, there's nothing in front of the absolute value bar, so you can start with an absolute value bar. So from our original parent function, we moved our vertex 3 to the right? So to do that, that would be the absolute value of x minus 3. And then 2 down, so then minus 2. All right, so that's kind of your thought process there. And remember, you can always punch it in to kind of check. All right, last one is kind of just a multi-step word problem. It says the map shows the number of tickets needed for small or large rides at the fair. So a couple things to note here. Tickets are $0.25 apiece. I know it's kind of hard to see. Large rides are 5 tickets apiece. Small rides are 3 tickets apiece. You do not want to spend more than $15 on tickets. How many large and small can you ride? So a combination type problem. So remember, we are thinking in terms of quarters here, not dollars. So $15 times 4 quarters per dollar tells me that that's going to buy me 60 tickets. 60 tickets. Okay, split up between large and small rides. Okay, so we will just say you just got to pick one. Let's say X is the number of small rides. You could flip-flop these, and Y is the number of large. And so we would go like this. This is kind of a this is a standard form type problem, right? So small tickets are 3 tickets per ride, so we would go 3 per X plus 5 per Y. So that's kind of my expression for total cost for X small rides and Y large rides. Okay, and then we can always spend no more than the money we have. So we can spend less than or equal to 60 quarters. All right, so that is kind of my inequality. And then we want to try to graph that. Okay, so remember on your graph which axis is which here. So your small is on the x-axis, so this would be a number of small rides here, a number of large, I can write sideways here. So think about your x and y intercept. All right, so your x-intercept is going to be 3x equals 60. So x equals 20. So that means our graph is going to go through the point 20, 0. And then our y-intercept would be 5y equals 60. So y equals 12. So it also goes through the point 0, 12. All right, so let's see, our graph is, I think, 10 by 10. Yeah, 10 by 10, so we will just count by 2s in this case, because that'll cover us everywhere. So counting by 2s, that'd be 0, 2, that'd be 4, 6, 8. Wrote a little too close there, sorry, that's a little bit sloppy. Same thing here. Okay, so I am just going to graph each intercept. All right, so 20, 0 goes through there. It also goes through, we said, what did we say? 0, 12. All right, and then it is going to be a solid boundary line because we could spend up to the money we had. So we're just going to kind of connect the dots here. See what we end up with. Okay, and just to maybe be sure, you can see that the way my slope is we're going down it's down 12 over 20, but actually, you know, it looks like down 1. It looks like down 6 over 10. So you could go down 1, 2, 3 over 1, 2, 3, 4, 5. So you can kind of split the difference there and see another point on that line. Okay, and then which side do we want to shade on? Obviously, we want to shade in here. So everything on that boundary line and in the shaded region represents the combinations you could do. So if you spend all your money and ride only small rides, how many could you ride in total? So that would be right here, 20, 0. So 20 small. All right, and it says, what does this correspond to on the graph? We would just say that's represented by the x-intercept. And then the last one, I think there's another part to this question. All your money on big rides. Okay, so same type of question there. So remember, it goes through 0, 12. So that would be 12 large. And that's represented by the y-intercept of our graph. Okay, so that'll conclude your lesson. You guys let me know if you have any questions. And remember, this is the last lesson. So after this, we start to study for your first test. All right, so thanks for your time. Hopefully this helps. And that is it.